Hi, welcome to this demo of Spectrum Protect version 8.1.13. We'll be showing you how to create a retention set and then have that copied out to AWS Glacier and deep-glacier. In this demo, we'll be using the command line to do this. And so what we'll be going through is, first of all, defining a connection. Then we'll go out and validate that cloud connection. We'll then define dev classes, define a storage pool with the pool type of retention, and then we'll go ahead and define the retention rule. We'll do a backup and create a retention set using those backed up data. And then we'll run the storage rule to copy that in-place retention set out to the AWS Glacier. We'll then go ahead and make that directory container pool, which contained the original backup of that file, unavailable, so that when we do a restore, that restore is coming from the cloud retention set. We'll show you how if you try and restore directly from the Glacier, it will fail because AWS Glacier requires you to first of all stage the data back, and that's usually an offline process, which will take quite a bit of time depending if it's in Glacier or deep-glacier. And once you stage that back, then you can do the restore from the Spectrum Protect client, and that data will be successfully restored. So with all that in mind, let's go ahead and get started so you can see this process from the Spectrum Protect command line. With that, I'm going to go ahead and turn it over to Jimmy to walk you through this.
We'll start off here by defining a connection. So this connection just has all of the cloud credentials telling you how to access the cloud. We use these for other operations, so these can be used for DB backup restore to cloud and also for container pools in recent releases. We have defined connection, the name of the connection S3con in this case, an ID and a password which correspond to the access key and the secret key from AWS. And then we also need a bucket name. We need a cloud URL to say which S3 region we're using. We see that it was defined. We can do validate cloud using the connection. So connection equals S3con just to verify that things are set up correctly there. So now that the connection's all set, we can define a dev class to use that connection. Define dev class. I'm going to call it S3 dev class. These have a dev type of cloud, and we have to give them the connection that we're going to use, the S3con that we just defined. Something new here is that there's a cloud storage class that we can use to specify. By default, it's default, but we can also define it or update it to use a different cloud storage class. For the purposes of this demo, the one we're going to use is Glacier, and that's specific to AWS. That just looks like cloud storage class equals Glacier. I forgot to give it the device class name, so that's why that failed. S3 dev C, so that's the device class we're updating here. We're just setting that cloud storage class to Glacier, and that time it worked. deep-glacier and Glacier, you can use both of those without anything on AWS. So we have that device class. The next step is to define a retention storage pool using that device class. It's going to look similar to what it might be for other retention storage pools, just with the main difference of using a cloud dev class. I'm going to call it S3 pool, and then I'm going to give it the S3 dev class. The pool type is going to be retention, which I'm going to abbreviate as RET. Script equals no for this one. So defining that storage pool, since the pool type was retention, it's automatically going to create a storage rule for retention with those defaults that we see in that message. And that storage rule is called S3 pool. We'll kind of see that in action later. For the next step here, I'm also just going to show that we have a storage pool called container pool. It's a directory container pool. This is where the new backups are going to go. That's already set up. And our node here, just to show that. We have node 1. We're backing up from node 1 into that container pool. In order to set up the retention rule now, we're going to say define ret rule. I'm going to call it 2 days. That's going to go from node 1, going to have a retention of 2 days. Active equals no, and then give it a destination, which is going to be that retention pool we just set up. Okay, so we have a retention rule 2 days defined to make retention sets based off of node 1, writing those into that S3 pool we just defined. So at this point, we have all of the stuff set up basically on the storage pool side of things. Any backups we do with node 1, we can start making those retention sets going to that new storage pool that we just made. In order to show that, let me pull up another window. This one will be just to show BA client. Here we have our BA client. I'm about to issue this command to back up a log file. We wrote that file without failure, and that went to the container pool. Now that we have that data in the container pool, we can define the ret rule name of 2 days, defining a new ret set using that retention rule. A retention set was created, and we can go ahead and start the storage rule for the S3 pool to populate the S3 pool with that retention set. We can get rid of this BA client for now. See progress happening in our act log here, and we see that the copy retention set completed with success. We have files that were copied over to the S3 pool using the retention rule of 2 days. Let's see what happens when we set the container pool to be unavailable. So we set the container pool to unavailable. That means that we won't be able to read from that primary copy. So if we do a restore from the BA client, we should try to read from that retention set in the retention pool. And that was based in Glacier. So what we're going to demonstrate now is that if we try to read from that, just to do a restore of that same file, the container pool is unavailable. We'll try to read from the cloud. The password, and I just replace everything. It says currently unavailable on server in the BA client, and let's see what we got on the act log here. We see that we couldn't restore from the container pool due to the access state of that storage pool. That was expected based on setting it to unavailable. Then we see the volume in our S3 pool that we're trying to read from, and we get this error that that volume couldn't be opened. The volume must be staged before you attempt to open the volume for read operations. So that's because we had it in Glacier, an archival cloud storage class that doesn't allow for direct reads. What AWS requires is that there's a separate request to, in AWS terminology, restore the volume. In our terminology, we're going to say staged. So the volume must be staged before you can attempt to open that volume. And then we see that the mount request for that volume failed, basically for the same reason. We had a retry that had the same results, and then the restore session failed in the end. What we would have to do then, stage volume. So the command looks like this, stage volume, and you give it a volume name. By default, that's all you need to issue that request to stage the volume. On the AWS side, it'll take several hours for that to be posted and to be ready to be read from. Where all the stage volume command does is issue that request, and then nothing else is happening. Send that request to the cloud, and then the cloud will do that work in the background. We're not actively keeping track of that. Just to look at what it looks like for this particular volume, there's this action parameter. Action equals stage by default. So if you want to issue the stage, that's what you would do. Alternatively, you can also say action equals preview. So that'll tell you what work may or may not need to be done on that volume. We see that the volume with that many bytes is in the Glacier storage class. Before you can read data from the volume must be staged. So we have an idea of how many bytes we're going to be staging. Another thing we can do, instead of doing it by volume, we can do it by retention set. So let's first look at our retention sets. We have retention set 1 that I set up previous to starting this demo, and then retention set 2 that we did just now. I'm going to try to do that stage volume now with action equals preview and with ret set equal to. So we give it that retention set ID. Let's again do action equals preview. So rather than just doing it on one volume, this will do it for all of the volumes in that retention set. In this case, I'm dealing with very small amounts of data. It's still just one volume in my case, but it'll give you a summary of how many volumes and how many total bytes you're going to be staging if you were to do this stage command with action equals stage. So touch base on another couple of parameters here that are optional. There's a duration parameter. By default, it's 3. That just tells the cloud how many days we want to keep it in that readable state before it expires back off into Glacier. By default, that's 3 days. If something has been staged, you can always update that duration to keep it there for longer or for a shorter period of time. There's that flexibility to set that, or you can just leave it to the default of 3. Then there's also a retrieval type in AWS. There's a couple of different options for how to retrieve these objects from Glacier. So there is bulk in their terminology, there's standard, and there's expedited. In our case, we keep the term bulk to refer to the bulk retrieval. Standard is the regular retrieval, and that's the default. And then we say urgent, just because some of the different cloud providers use different terminology, we use urgent to refer to that expedited. So not all of those are supported for all cloud providers. One other thing to note is that the expedited or the urgent can't be used for deep glacier. So that's another option that's there for 3. If you set deep glacier, then the urgent won't work there. Go ahead and look at what happens when we actually do the stage, and we'll do it on the retention set. Stage volume, retention set 2, action equals stage. I'll do retrieval type equals standard. That's the default, but I'm just going to explicitly set it here. The message we get, the staged volume command is being processed. The staging process was started for the following number of volumes, 1, since that was all that was in the retention set. The duration of availability in standard storage was updated for the following number of volumes, 0. So if we issued this and there were some volumes in the retention set that had already been staged, we would still issue that the basically restore request is what AWS would call it. And that restore request includes that duration of 3 that we had by default. So if the duration of one of those staged volumes was different than 3, we would issue that request. And on the AWS side, we wouldn't need to restage it, but it would just update the expiration date from the standard storage to be in accordance with whatever we set on here. And the first value is just things that needed to be staged that we issued those requests for. If we set this on the volume instead, we'd get a different message here, but it kind of summarizes the same thing. This is just a summary for the retention set specifically, since we do have potentially multiple volumes in each retention set. Now that this is going, it takes hours on the AWS side for the standard retrieval type for these to be put into that readable state. And we don't have any active process here. So if I do queue-process, there's nothing there. While that stage volume kicked off that restore request on the AWS side, that's happening purely on the cloud side. If we halted the server and brought it back up, that AWS would still be working on getting that volume staged. Instead of having a queue process, we just have a separate action type to monitor the ongoing progress. We can say check status for that ret set. When that stage volume command was issued, we got the following information from the cloud provider. We have 0 volumes that are not stored in archive storage classes. We have 0 volumes that were staged from archive storage. We have 1 volume in the process of being staged, and we have 0 volumes that still need to be requested for staging. So just kind of a summary for that retention set. Where are our volumes? So for instance, if our dev class was in standard storage, we wouldn't have anything in archival type. This number would reflect that. This is our volumes that aren't even in Glacier. Retention set 1, this has already been staged. For this one, we see a different message that just tells us that everything's available. We don't really need to worry about what is staged or in the process of being staged. But in this case, for retention set 2, we do need that just so we see that we still have a volume in the process of being staged. If we're failing to read data from that retention set, that kind of explains why that is. We can also do check status on the volume itself. Kind of gives us the same information, but just specific to that volume. We see that it's in the process of being staged. The idea here, we have the 3 action types. We have preview. The goal of preview is to tell you what amount of data you would be staging by doing a stage request. The second action of action equals staged actually does the request. And then the third action of action check status is to see what's the current state of whatever's going on in the cloud, whether or not we issued the request already. So if we had done action check status beforehand, it kind of gives us similar information to what the preview would give us too. I mentioned that retention set 1, I staged it yesterday, so all of the volumes in that retention set are available to be read immediately. That's on a different storage pool, but we can see for completeness, if we pull up our BA client again, and we try to do a restore, I'm going to change it to a different file, just another log file. This is the one that I backed up yesterday. So since that volume had been staged, if we can read from that. Okay, so restoring finished, and let's look at the act log now to see what that did. We couldn't read from the container pool, so we opened this volume, which had been staged already, and we didn't have any errors for that, and then we closed that volume and end the session, and the restore was successful. All that was keeping us from reading that first time we tried that restore request on that other file was that it hadn't been staged yet. If we came back to this in a few hours and tried to do that same restore that failed, after seeing that retention set 2 has fully staged, then we would also get that successful read. Queue device class, let's more specifically look at S3 dev class. We'll do f equals d to get the detailed output here. So we can see cloud storage class equals Glacier here. Let's just walk through some of the other options there. Update dev class, we'll do S3 dev class. So we set it to Glacier in this case. By default, in SP, what we call it is default, which maps to standard in AWS. So if we do default here, update dev class with that S3 dev class and its cloud storage class. Cloud storage class equals default. That should work. So now if we look at that f equals d again, we see the cloud storage class is default. This only impacts new objects that we're writing to our cloud. So at this point, when we've updated it to default, any new volumes we made won't be stored in Glacier. So those will be written to standard storage. You might end up with a storage pool that has a mixture of volumes in Glacier and in standard. Okay, so that one shows us deep-glacier here. And yeah, at this point, any new volumes we wrote would be put into deep-glacier. You might end up with a combination of different places if you're changing this a lot. The general expectation is that if you're setting up a storage pool specific for retention and you want to use archival storage for that, you probably won't be messing with this too much. The rationale for having that cloud storage class on the device class rather than on the connection is that you could have separate device classes for each one, so using the same connection. So I could make a new dev class, gonna just call it standard S3 dev class. It's gonna have a dev type of cloud. It's going to have a connection of S3con. This one we're going to say cloud storage class equals default. Okay, so these two connections now, we have S3 dev class and standard S3 dev class. These both use the same connection. They use different cloud storage classes, but you could using the same connection while still having a dev class that's going to Glacier. Or if you need to update your password or your ID, all you need to do is update connection, and then you can say ID equals new ID, and that will update it in all the places that that's used. The connection can be used for different device classes here, and then it can also be used for cloud container pools. The device classes and the cloud container pools all have their own cloud storage class parameter, so it can be used in kind of a variety of ways while using the same connection.
Great, thank you, Jimmy. Be sure to check out the other videos I have on using retention sets and having those retention sets copied out to cloud, retention sets copied out to tape, using the operations center with retention sets, using retention set holds, and all the other great features we have around retention sets. Thank you very much.